We are going to be looking at some different kinds of some special right triangles today, some 45, 45, 90 and some 30, 60, 90 degree triangles, just to kind of give you a quick review of some of their special properties. So here's a 45, 45, 90. The hypotenuse will always be whatever the legs are times the square root of 2, and these should be on your master formula sheet as well as on your note sheet there. So that is that. And then a 30, 60, 90 degree triangle has these properties. So hopefully you will be able to look at those and figure those out. Okay? All right. So in this first example, I have given you a 45, 45, 90 degree triangle. So what you need to know, I'm just going to kind of write the properties down. If this is x and this is x, then this will be x root 2 on a 45, 45, 90 degree triangle. So I have given you one side and you have to find the other sides. Okay? So for the first row of the table here, side A is 3, which means obviously side B is going to be 3, 2 on a 45, 45, 90 degree triangle. And then side C will be 3 root 2. Okay. If side C on the next row there is 6 root 2, you can go backwards. If the hypotenuse is 6 root 2, you can go backwards and each leg will be side 6. Okay. And then the last one, if the hypotenuse is 5, you have to go backwards to get the legs. And what you're going to do to go backwards and get the legs is you are going to divide this by the square root of 2. And so what you have is you have 5 root 2, 5 over 2. I'm skipping a step for you, so I will show you this. So you have 5 over root 2, can't leave a radical in the denominator, so you have that, and you will have 5 root 2 over 2. I do not want decimal answers here. I want exact answers. So no decimals, and you need to simplify the radicals for me, please. So that's that. Okay, moving on to a 30, 60, 90 degree triangle. The short leg will be x. The long leg will be that distance times the square root of 3. And the hypotenuse will be 2 times the short leg every single time. All right, so we'll do a few of these, okay? So if the short leg in the first row is 7, then the long leg, or side B, will be 7 root 3, and the hypotenuse will be 2 times 7, which is 14. Okay? In the next row, if the long leg is 9, and if you look at your proportions, the long leg is the square root of 3 times the short leg. So to get back to the short leg, you're going to need to do 9 divided by the square root of 3. Can't leave a radical in the denominator. So you will have 9 root 3 over 3, which of course simplifies to 3 root 3. So that's that. And then the hypotenuse is twice that short leg. So you have to go 2 times 3 root 3, which of course gives you 6 root 3. Okay? And then the last one, if the hypotenuse is 7, you can go back and find the short leg by cutting it in half. So that would be 7 halves. And then you can find the long leg by taking the short leg times root 3. So 7 root 3 over 2. All right, so those are the special right triangles that we just wanted to remind you of here. All right, now we need to talk about bearings, okay? So first of all, this little slide is not on your notes sheet. I just want to show you what bearings are, just so that you get an understanding of how we measure them. Bearings are something that describes a position from the origin, basically. So I've got Goldilocks and I've got a wagon here, okay? When you describe bearings, this is what you do. Obviously, here's the origin. That's where you're going to describe an object's position from, okay? So what you need to do is you need to tell me, first of all, if the object is north or south of that starting point, okay? And so we're going to do Goldilocks first. Goldilocks is always obviously north of that starting point, okay? And then you're also going to tell me, is it east or west of that starting point, okay? And Goldilocks is to the east of the starting point, so she will be east. Okay, then you need an angle in between. And the angle in between is always how far off of straight north you are. Okay, so how far off of straight north you are would be this angle in here. Okay, not this one. That's not the one I want. I want the one how far off of straight north you are. So if you were to estimate Goldie's angle there, and I'm not going to get a protractor out and do it, but she is probably, let's say, 30 degrees off of straight north. So her bearing would be north 30 degrees east. Okay. Now if we look at the wagon, it is south and it is west of the origin. Okay. And if you kind of figure this out, again, the angle you want to measure is how far off of straight north, that north-south line they are. Always off of the straight north-south line. So this is the angle that I'm worried about. And if you estimate that angle, I would say it's probably 70 degrees. I'm estimating, I'm not getting a protractor out, but let's just call it that. Okay? All right, now we're going to do some story problems here, and these are a little bit tricky, just so you know, so bear with me. Ha ha ha, bearings. Anyway, here we go. An airplane leaves a runway with a bearing of north 20 degrees east. Okay, so that airplane starts right here and heads north, and then is 20 degrees off to the east. Okay, that's what that means. After they fly 1 mile, they turn 90 degrees towards the south, and they go 2 miles in that direction. And what bearing should be used to locate the plane? Here's the problem. When you draw your picture, you don't really know how to draw it. So some of you might have drawn it like the left-hand picture, and some of you might have drawn it with the right-hand picture. Okay? If you drew it like the left, then this is where the plane ends up. After it travels, it goes this way, it turns 90 degrees towards the south, and it goes this way for 2 miles, and here's where the plane ends up. I know, it's beautiful, isn't it? There's the plane. Okay, the problem is that might be the case, and if the plane ends up over here, it has a bearing of northeast of where it started. Okay? Or some of you might have drawn the picture like this because you're not getting a protractor out, you're not measuring everything to scale. The same thing, some of you might have drawn the picture like this and said, oh, there's a 20-degree angle right there. The plane heads and it heads this direction after it turns. And then in this picture, the plane ends up over here. And in this picture, it has a bearing that is southeast. And in this picture, the bearing is northeast. And the problem is you don't know which picture is right, okay? But I do know this. Every time you do a bearings problem, you always want to find the angle in the triangle that hooks to the origin. So this is always the angle that I want to find. Always find the one that's connected to the origin. This is the one I want to find. Okay, now, if you think about this, you have 90 degrees to work with from here to here. You have 90 degrees, okay? You have used 20 of them up right here. So this picture will be correct as long as this angle right here is less than 70 degrees. Okay? As long as this angle right here is less than 70 degrees, then this picture will be okay. If that angle is more than 70 degrees, then you're going to have to go to the right-hand picture. And I'm not going to know until I find that angle. Okay? So that's what I'm going to do. I'm going to find the angle theta, and you're obviously going to be able to use SOHCAHTOA here because this is a right triangle. And so I will go tangent at that angle is opposite because that's what I have. I have an opposite and I have an adjacent. So opposite is 2, adjacent is 1. I will put that into my calculator like this, and again, make sure you're in degree mode so that your calculator spits out an angle in degrees, and you will get 63.43 degrees. Okay, so the left-hand picture is the correct one here because this is 20 right here, and then this, the angle theta is 63.43, and that's still less than the 90 degrees that I have to work with in that quadrant of my picture. Okay, but now to answer the question, I do know that I am north and that I am east. The problem is I need to know the angle that goes in here is how far off of straight north you are. So what I need to know is I need to know this 20 degrees plus this 63.43. This is how far off of straight north I am. So I am 20 plus 63.43, or I am 83.43 degrees off. Okay, and I'm going to make this so that I have more space to write. Okay, so that's how that goes. This picture is null and void. It does not do you any good. All right, one more. Very similarly, okay, so here we go. A plane leaves a runway heading north 30 degrees west. So they start off going to the north, but they're 30 degrees off of straight west. So let's say that this angle right here is 30 degrees. So they're heading this way. Okay, they fly a third of a mile, and then they turn 90 degrees towards the southwest. And they fly for 1 mile. What bearing should be used to describe the plane's position? So the plane may end up down here. We really don't know. If it ends up down here, it has a southwest bearing, we know. Okay? Or if you didn't get your handy dandy little protractor out, you could still draw the same picture. This angle would be 30 degrees off of straight north. And if it flies and then it turns and it ends up over here at the end of doing everything it needs to do, then this one has a bearing of north. Oops, west. Okay. And we don't know which picture is right. So what we're going to do is we're going to find the angle that hooks to the origin. I'm going to find the angle in the triangle that hooks to the origin. In this picture, that's this angle right here. Okay? I'm going to find it, and then I'm going to talk about which picture would be correct. Okay? In either picture, it's the one that hooks to the origin. And it's the same trig functions either way. So from that theta, I have an opposite, which is 1, and adjacent, which is 1/3. So I will go tangent at theta, and it's the same for either picture. Your opposite and adjacent are your same. Opposite, which is 1, over adjacent, which is 1/3. And of course, dividing by 1/3 is the same as multiplying by 3. So that's the same as figuring out where tangent is 3. Okay? Then you're going to put that into your calculator as an inverse because you're missing the angle. And your calculator will spit out 71.57 degrees. Okay, so here's what I want you to think about. If you go back to your pictures, and I'm going to look at the first picture first, the question is it possible for this angle right here to be 71.57 degrees? Is that the right picture, or is this the right picture? Okay, and here's what you need to think about. Over here, again, you have 90 degrees to work with from here to here. Only 90 degrees. Well, if this is 30 and this is 71.57, you're over 90 degrees. So I know that this can't be right. Okay? And that picture is not going to do me any good. So I'm going to go over here. So I know that the answer to this question is that the plane ends up down here. I know that it has a southwest bearing. And the angle that goes in here, again, is how far off of straight north or south you are. So the angle that goes in there is actually this angle right here. Okay? And I hope that you can picture that these three angles, 30 plus 71.57 plus this one I need to find, should add up to 180. Okay? So if I take 180 minus 30 minus 71.57, that is going to give me that angle that is going to go in between, which then ends up being 78.43 degrees. All right, and that is it for today.